I will be your host today, guiding you through this event, which will last about 1.5 hours. We recently published the study Breakthrough Strategies for Climate Neutral Industry in Europe. This was in April, and maybe my colleague could be so kind and add the link to the study into the chat. And we had already published the executive summary in November, so you may have already heard about that study before. And now, today, in this webinar, we're going to present the results together with one of the partners that we conducted the study with, the Wuppertal Institute. On the agenda today, we do have two presentations. The first one will be why EU industry needs to kickstart the transition before 2030, where we will also have deep dives into the steel, the chemicals, and the cement industry. And at the end of this presentation, there's time for your questions. And afterwards, there will be a second presentation called A Policy Roadmap for the Decarbonization of Industry. And again, there will be time for your questions afterwards. Also, we have a few polls here and there. The first one you can still participate in, letting us know from which country you're tuned in. And by 12:30, we should then be finished with the event. Before I hand over to my colleague to start with the presentations, I would like to make you familiar with the Zoom environment. Most of you probably know it by now after more than 1 year of heavy online events, but still for the ones who are here for the first time or who can't remember what it works like, let me let you know how we are going to use the room today. You see at the bottom of your screen you see three boxes. Please ignore the Handheben or like raise your hand one. I will take that off in a minute because unfortunately we're too many, so it wouldn't be possible to use the hand raising. But you can get in touch with us through the chat box and through the Q&A box. The chat box is meant for your organizational and technical questions, and my colleague Maxi Matzanke from the events department will take care of those. Maybe Maxi, you can quickly switch on your camera so the audience can see your real person, and she's there. Hi, Maxi. So she'll be looking after your technical and organizational questions. They will remain invisible for the rest of the audience. Now, there's also the Q&A box, which is meant for your content-related questions. And you can put anything on the presentations into there. And we have two colleagues looking after those questions and trying to sort of cluster them so that we can take as many of them into the Q&A session after each presentation. The two colleagues, let me introduce to you also. It's Philipp Hauser and Paul Münich from our team industry in Berlin, and maybe you two can also quickly switch on the camera so the audience can see your faces. Hi, Philip. Hi, Paul. Thanks for looking into the Q&A box throughout the event. Now, we are also recording this webinar in order to make it available afterwards. You will be able to find it on the website in a few days. So that explains why we are recording it. And I have a little control monitor here to my left, you will see on the right, where I can check that you see what you're supposed to see. So don't worry if I keep looking into that direction. Okay, now having said that, let me introduce you to my colleague Frank Peter, who's the director of the industry team at Agora Energiewende and who will be moderating the middle part of the event, so to say, the presentation and the Q&A session. Welcome, Frank.
Hello, everybody. Good morning.
And I think with this, I can now hand over to you. And I will stop sharing my screen. And you should, and the floor is yours, Frank.
Thanks very much, Nicola, for the introduction. So Industrial decarbonization is becoming a greater topic by week, I would say, at this point of time. Many countries in the world are heading towards climate neutrality, latest by the mid of the century. So it's quite clear that from now on, every investment in industries need to be compatible with climate neutrality in the long-term perspective. And also the EU increased ambition to reduce emissions by 55% compared to 1990s level by 2030 will lead to the fact that industry will face also higher ambition. It is somewhat a silent secret at this point of time that most of the increased ambition needs to be covered in the ETS sectors. So we will see very likely raising carbon prices also in the future. We have experienced this already over the past week, and this is putting a lot of pressure on European industry. And we want to discuss today with our experts from the Wuppertal Institute, Stefan Lechtenböhmer and Clemens Schneider, and our internal experts, Vido Vitecca and Camila Oliveira, how this could be done in the sectors of steel, cement, and chemicals. And therefore, we have prepared a study on the breakthrough strategies for climate neutral industry in Europe. And most of the presentations today will refer to that, but we will also come up with some quite new numbers, new estimates from our side on the future development of the industry, and to, let's say, put also something new on the table that you may have not heard before. That's it from my side as an introduction. Nicola has prepared a second Mentimeter, and Nicola, please tell us what it is about.
Yes, we would like to know multiple choice. No, this is not what we would like to know. I apparently forgot to type in the question. No, let me say it. The question is, what is your professional background? And you see you have different options once you type in the code for the menti.com, which you see at the top of your screen. And Maxi will also put the link into the chat, and you can choose between. Is your professional background steel industry, chemical industry, cement industry, or another industry? Is it politics? Is it science? Is it non-governmental organization or non-profit organization? Are you maybe still a student or anything else? And the question is, what is your professional background? And you don't have multiple choice. You're only allowed to vote once. So don't get irritated by the title you see at the top of the screen. I just forgot to type in the actual question, which is, what is your professional background? And we do see that people are still typing it in. And apparently there are, looking at the industry part, a majority of other industries, but still a few representatives from industry, steel, chemical, and cement. We also have quite a few representatives from the science sector, followed by NGOs. There are also students in the audience, a few representatives from politics, and a big group of other. If you like, you can let us know in the chat, just everyone on the panel, what the other sectors are. Of course, we cannot put every sort of job into this, but 13 seems to be quite a big amount of people who do not find themselves in any of the other groups that we have on display here. So maybe with that, and keeping in mind from where people are located, I now hand back to Frank to start with the content part.
Thanks, Nicola. Very interesting, but just to let you know, for the production of our study, we have been in very close touch with industry stakeholders to discuss the strategies, the technology strategies, but also the policy strategies going forward. So what we are presenting here is not just our own and our partners' experience. It's also broadly discussed already with industrial players. And so industry maybe already knows what we're going to present today, because we are so much in exchange, and we are presenting it now to the audience and to, let's say, the wider public, what our estimates and findings are. And Stefan, I would like to introduce you and to give you the floor to give us a reason why does industry need to step up the game here and also enter the race towards climate neutrality prior to 2030. Stefan, please, the floor is yours.
Yes, thank you, Frank. Yes, why is the EU industry to kickstart the transition before 2030, and why is that really necessary? Before I start with that, many thanks also from my side, from Wuppertal Institute, to all who prepared this webinar and to all who prepared the study. And of course, warm welcome also to you, the audience. We are happy to share our results with you. So it's really very important to start with the transition very early, immediately, definitely before 2030. Frank has already mentioned changes are happening now almost weekly. So it's really important to go for climate neutrality in our basic industries. It's urgent. As our results show, it seems to be possible, and it could also be a major opportunity for European industries and for the European economy as a whole. I will try to give you a first flavor of that before we go into detail with the presentations of my colleagues. Next slide, please. It is important to reduce industry emissions. Here you can see the role of industries in the global greenhouse gas emissions, and the global CO2 emissions from industry are taking everything together around 40% of global CO2 emissions, and only 5 sectors, so steel making, cement making, chemical industry, aluminum and paper, are responsible for over 60% of industrial emissions. So it's really very clear that industrial emissions need to be reduced in order to achieve the Paris targets. And what is more, in industry, emissions have been growing recently. This is the sector with the largest growth, and we will see also in the future growth as material demands for steel, cement, plastics is going to rise globally, at least. And that makes it clear that the transition to climate neutrality is very urgent in these industries. Next slide. And another argument why it's really urgent is that climate neutrality by 2050 may sound a long way to go. May sound as we still have some time, almost 29 years until 2050. However, when we look at heavy industries, at blast furnaces or integrated steel mills, at chemical industries, for example, steel crackers or cement kilns, we see that climate neutrality by 2050 is only one investment cycle away. And that, as Frank already mentioned, that means exactly all the investments done in these industries today basically have to be climate compatible. They need to be climate neutral ready, at least. Otherwise, they really severely risk to become stranded in the future. And I think that's also one of the reasons why there is some hesitancy in industry, at least in Europe, to invest in this technology. And therefore, it's really important to come forward with the right technologies and the right solutions in order to invest in our industrial future. And in this respect, for the EU industry, very much is at stake. Next slide, please. Here you can see the situation in Europe. And according to our estimates, in steel industry, in chemical industry, and in cement industry, between 30 and 50% of all the existing CO2 emissions are locked to assets that have to be reinvested. So that's really an important factor. We see industry in the basic production needs to really reinvest in the next years into their assets. And if you look on the right side, we are talking here about in total sectors directly affected in iron, steel, chemicals, and cement, which employ almost 1 million workers in the EU only. So that's really important, and that shows how much is also at stake for our industrial future, for our jobs in Europe, because many of them are linked to these investments that we have to take. Next slide, please. This figure shows us the role that industry has in our climate ambitions to 2030 and 2050. And it shows also a couple of other things. First, emission reductions by industry have been pretty substantial between 1990 and 2010. So emissions have been reduced by every decade by roughly 150 million tons in European industries. However, since then, they have been stagnating. So we haven't seen really substantial further emission reductions. That may have different reasons. So many of the quick wins of the easy potentials probably have been exploited by 2010 already. And also we see maybe the fact that we now need to reinvest in really significant technologies. And if we look at the future, the role industry has to play, again, we see that even those past trends probably are not strong enough. By 2030, which is less than a decade now, we need to really come back at least to the declining trends we saw in the 1990s and the early 2000s. So roughly over 150 million tons of CO2 reductions are necessary. And what is even more, by 2050, we need to be near climate neutral, in some scenarios, even negative in industry. So that really means by 2050, we have to completely exchange all the big emitting assets in these industries. So that's really tough and really short time we have to do for this. The good thing on this picture is, thank you, Guido, that the technologies are already there. We have mainly three processes or three levers available in industry. The first one is we need new processes, new technologies to invest. So that's a big challenge for industry, but many technologies are already known and available. So this is converting primary steel making to hydrogen-based DRI route, to go for chemical recycling in the chemicals industry, for example, and to do oxy-fuel and CCS in cement industry, but a couple of others. But those new technologies typically also come with fuel switching. So going towards power to heat, going to use hydrogen, for example, in steel making, and going to use more biomass for feedstock and energy uses. But there's also a third big lever that we should not forget in this context. This is improving our circularity, going for more circular economy and higher resource efficiency by enhanced recycling rates, by eco-design, enabling to use less materials for our products and services, and by lots of increased efficiency in manufacturing and construction. I will give you some more details on what our study found out on those. On the next slide, we will see the technologies. This is just a brief overview. When you go to the study, you can see that we have assessed 13 key low carbon technologies for the 3 main sectors, steel, cement, and chemicals. And many of those technologies can be market ready before 2030. So important is to say they can be market ready. That, of course, needs lots of ambition by industry and by governments together to make those technology really through to the market. However, they are known and we can assess their potential, and they have big potentials to reduce greenhouse gas emissions and to modernize our industries in the European Union and globally. But technologies are not the only thing. If you go to the next slide, thank you, we see that using those suite of just 13 key technologies together with a couple of others, we can already reduce greenhouse gas emissions of European industries by 2030 by roughly 1/3. And by this, roughly fulfill the needs to achieve that 55% reduction targets of the EU. So that means that only these 3 key industries in some key processes will be able to deliver an important share of the EU's greenhouse gas emission targets. That again shows how crucial it is to speed up with the deployment of these technologies, because they can really not only modernize our industries, dissolve potential lock-ins in investment, but they can also really already by 2030 substantially contribute to greenhouse gas emission reduction. And of course, they are indispensable to come to zero by 2050. Now, next slide, please. And let me also emphasize that technologies and fuel switch are not the only solution. It's of course clear technologies are expensive and renewable energies, sustainable energy supply for these industries is also expensive and needs lots of resources. But the main lever that we have to enable us to do this is to do more circular economy and to reduce the amount of green energy and infrastructure needed to make the EU industry and to make EU industry less dependent on imports from other regions. So, as probably many of you already know, secondary materials use 50 to 90% less energy than primary materials. So using secondary material is a really strong energy efficiency gain instead of primary materials. And that also is true for the new breakthrough technologies. So in any case, even if we are successful to go to climate neutral production, circularity will help a lot in easing those developments. And therefore, it will massively reduce the investment cost the industrial transition will have for Europe towards climate neutrality. And that means that we have to really, on top of changing our industries technologically and from the energy supply side, also think about the value chains and make them much more circular by increasing recycling rates, by avoiding downcycling, by increasing material efficiency in design and production, and by implementing circular business models, using materials as a service. All this will substantially help to make it really realistic to mainstream all the technologies mentioned in the report by 2050. So just to concluding, technologies and strategies for making industry climate neutral are available. They can contribute significantly to our climate target, but what is more, they offer us a big chance to modernize our industries and secure significant jobs and labor and development in the European Union, but they can also help other countries to come forward with a climate-friendly and sustainable industry model. Thanks a lot, and now my colleagues will give you more details for some sectors on this.
Thank you, Stefan, for this introduction and this broad overview why this transition has to start now. Vito, it's up to you to dive us a bit deeper into the steel sector. Clearly, this sector with the highest ambition by the sector itself and the most companies ready to move. Please tell us why.
Yes, thank you very much, Frank, and thank you, Stefan, for the presentation of the overall framework. Now, I want to do a deep dive on steel on the question, what's the state of play of the industry transition in the steel sector? Today, the steel sector is the largest emitter of the industrial sector. It is mostly relying on coal, but as we will see in this presentation, this can change substantially until 2030. Currently in the EU, we have two main production processes. 60% of steel are produced through the coal-based blast furnace route. This is the primary steel making route, and 40% of the steel is produced via the secondary steel route. If you look at the emissions, you also see where the challenge lies ahead. The integrated blast furnace route is responsible for 180 million tons of CO2, whereas the secondary steel route today only accounts for 8 million tons of CO2, if you only consider the direct emissions for both routes. We have seen this slide before. We really think that the deployment of technologies that are compatible with climate neutrality well before 2030 is the key. And this will allow the steel industry to reduce its emissions by 1/3 by 2030 already. The two technologies that we identified as most suitable for this task is direct reduced iron, both with natural gas and then increasing shares of clean hydrogen, and an increase of the secondary production via electric arc furnaces. And those are the two that I will also highlight in the following. Now, taking a step back, what is the current status quo? We would say that the EU steel industry is really at the crossroads now, because we've seen the numbers before. 50% of blast furnaces will reach the end of life before 2030. And in this figure, you can also see the country level breakdown, which countries in the EU are affected by that. This is a golden opportunity to use this kind of reinvestment windows to invest into climate neutral technologies. But we also need to make sure that we have the regulatory framework that these investments will actually happen. And you can see on the EU level, the aggregate numbers here highlighted in pink, that we really need to start moving. Another really important one when it comes to the reinvestment requirements is, you may ask the question, well, maybe steel industries will just reinvest into coal-based blast furnaces. But I personally believe that there's probably no business case anymore for such reinvestments. And there's a very high risk of these blast furnaces that they will end up as stranded assets and the carbon lock-in prior to the end of their lifetime. If we want to have a smooth transition in the steel sector, it is really key to use the reinvestment windows to deploy key technologies. If we look at primary steel making, we see that DRI technology is already mature. Today, I think there's no plant that runs on 100% clean hydrogen yet, but it is possible to operate these plants with natural gas. This would already save emissions around 2/3 of emissions compared to the coal-based blast furnace route. And then later on, as clean hydrogen becomes available as part of the European hydrogen strategy, it is possible to increase the share of clean hydrogen without any retrofit of these DRI plants. And this technology will become compatible with climate neutrality. So DRI really ticks the two important boxes. It is available now to address the reinvestment requirements, and it is compatible with climate neutrality by 2050. Now, if we look at the current status quo, in Europe, what we see is that we do have some front-runner countries that you see on the left-hand side that have already announced primary low-carbon steelmaking capacity by 2030. And you have other countries on the right-hand side where this is not the case yet. Basically, as I said before, the challenge is to more or less match the reinvestment requirements 100%, because otherwise there's a big risk of either ending up with stranded assets or with losing the steel capacity in Europe, because companies don't really have a business case to invest in either the conventional technology, and I explained the reasons before, or to invest in the new technology because there's no regulatory framework yet that will make these investments possible. The really good news is that the EU steel industry is in the starting gates. You can see that by 2030, we already have announced targets of steelmaking companies to build 28 million tons of low carbon steelmaking capacity. However, there's also this stark imbalance amongst EU member states, and many member states in Southern Europe, in Eastern Europe, do not have steel companies yet that announced to build green steel capacity by 2030. Another challenge that I also want to highlight is that even for those front-runner countries that already announced primary low-carbon steelmaking capacity, what is still missing is the regulatory framework. So I believe for all of these countries, we don't have a final investment decision by the steel companies yet to actually build those capacities, because two things need to be addressed there: the high capital expenditure for the investment into DRI plants, but also the higher operational costs to run those plants on natural gas and increasing shares of clean hydrogen. Now, a summary: what is actually needed to kickstart the transformation in the steel sector? We have seen that 50% of the EU's blast furnaces require relining, which offers a great opportunity to reinvest into key low carbon technologies. 10% of this capacity can be converted to electric arc furnaces to produce, to increase the share of secondary steel. But the big challenge will be to convert 90% of this primary capacity to DRI plants to produce 41 million tons of direct reduced iron in the year 2030. This also comes with the challenge of a huge additional capex requirement. We estimate it to be around 27 billion euros for the EU. And this is a calculation that we did assuming that by the year 2025, we built around 7 million tons of DRI capacity in Europe. And on the OPEX side of things, for the operational costs to operate those plants with natural gas and increasing shares of clean hydrogen, there is also a substantial additional OPEX requirement of between 30 to 60 billion euros in the year, actually over the entire period, because we believe we would need some a mechanism such as a CFD that go over a longer period than just a single year. So one would have to commit to already pay these hydrogen costs for a longer lifetime than just 2030. And this scenario was assuming a 65% share of clean hydrogen in 2030. Now, a couple of brief, very high-level policy recommendations. To address the capex requirements, it is important that the EU and the member states make sure that part of the recovery fund money that is out there now to address the negative impacts of the corona pandemic is used to invest in low carbon steelmaking technologies. You have seen the overview of the countries that are affected. A second lever is to use money from the EU Innovation Fund that funds up to 60% of the investment costs. But we also need to say that currently there are not sufficient funds there to do so for all the required investments by 2030 in the steel industry. And the EU Innovation Fund does not only cover the steel industry, but also other sectors. On the OPEX side, the industrial strategy proposed the introduction of CCFDs on the EU level paid by funds of the EU Innovation Fund. This is a very important signal and a great start, but also not sufficient to address the scale required. And then last but not least, one thing that is also possible is to strengthen green lead markets so that, for example, car manufacturers buy the green steel directly, and they cover the additional CapEx and OpEx costs. We have seen recent announcements by Daimler and also by Volvo and Scania in Sweden to use green steel as early as 2025. So this is also a very important policy instrument that should be implemented on the EU level to make sure that the market can also demand green steel and reduce the amount of subsidies needed for this transition. Thank you very much.
Thanks, Vito, for the steel sector introduction and the deep dive. It's now up to Camilla, I guess, to give us a more detailed input on the chemical sector.
Yes, thank you, Frank. Good morning, everyone. Jumping to chemicals. Next slide, please. Thank you. So the European chemical industry caused 18% of industrial emissions. It is the third largest emitter of the industrial sector, but it is the largest energy user of the industrial sector since it uses energy and non-energy hydrocarbons for energy and non-energy purposes. The demands of energy can be met with power-to-heat technologies that I'm going to show you in the next slides. But the biggest challenge is the non-energy share of the chemical industry, since the sector will still require carbon feedstock for its products, even in a GHG neutral world. In this study, we selected the three largest sources of emissions in the chemical industry. Industrial power plants, being represented by combined heat and power and natural gas-fired boilers, steam crackers, and hydrogen production for ammonia. Next slide, please. So for these three largest sources of emission, we selected 3 kilocarbon technologies that can be deployed before 2030. Those are power to heat, green hydrogen for ammonia and methanol production, and chemical recycling of plastics. Starting with power to heat. There's a big opportunity to deploy power to heat in the industry, especially with accelerated coal phase out in Europe. So the idea is to have a hybrid use. Heat pumps and electrode boilers could operate when renewables are abundant and electricity is cheap. Otherwise, combined heat and power would work. If we see this graph, there's the comparing the efficiency or coefficient of performance in the case of heat pumps of power to heat technologies and hydrogen boiler technologies. The power to heat technologies are the pink bars. And we can see for all the ranges of temperatures, power to heat technologies have a higher efficiency than hydrogen boilers technology. So it should be considered first. Second slide, please. Now jumping to plastics. The plastic value chain in Europe account for 130 megatons of CO2. We have emissions in the upstream of oil, in the refinery to produce naphtha, in the steam crackers, polymerization, and in the end of life of plastic. Here we considered incineration as the final disposal, since it is the dominant final disposal for plastic in Europe today. Next slide, please. And chemical recycling has the potential to reduce the emissions from upstream by ideally avoiding the emissions from virgin feedstock production and also avoiding the emissions from final disposal of plastics. Next slide, please. And also to reduce the emissions from steam crackers, conventional steam crackers should be replaced by electric steam crackers or should be retrofitted with CCS. This table, we can see some pilots and demonstration projects in Europe that is already happened for chemical recycling and electric steam crackers. So the technologies are almost market ready, but of course, still not economically competitive. And what is very important to say here is that the chemical recycling alone is not the solution for the chemical sector. We should reduce the demand of plastic and avoiding generating plastic waste in the first place by material efficiency, replacing single-use plastic, improving design for use, for repair, and recycle mechanically. So chemical recycling has an opportunity to deal with the waste that cannot be solved with reuse, repair, or mechanical recycling. Next slide, please. Finally, hydrogen. Hydrogen will be needed in industrial sectors that lacks an alternative of decarbonization options, such as chemical feedstock for ammonia, methanol production, and chemical recycling, and also as a reaction agent in steel sector, as Vido has already shown. We project that the hydrogen demand from today until 2050 will be constant, around 300 terawatt hours. But the biggest difference that today, the refineries are the largest user of hydrogen. And with electrification, we assume that the refineries will be closed in 2050. So the steel will be the largest user of hydrogen in the future, followed by ammonia production, chemical recycling, and methanol production.
Thank you, Camilla, for the chemical sector deep dive. We have now the cement left, and Clemens, please ride us through.
Thank you, Frank. Hello, everybody. And yeah, we're jumping now into cement. Please go to the next slide. Thank you, Vido. Yeah, this is an overview about what the cement industry has been thinking about when approaching 2050 in their roadmap, with the initial stage of 2030, you can see here. So you can see that until now, or 2017, which was the base year in this in their study, relative emissions, so relative to a ton of cement, decreased by 15%, starting from 1990 as a base year. And the cement industry, in their roadmap, they want to achieve 472 as a relative target per ton of cement. What are they planning now to achieve it? You can see that they are planning levers within the clinker production. This is in violet. And this is about thermal efficiency. This is about using other fuels. So we're mainly replacing coal. And this is also about using some new materials to substitute limestone as a feedstock, so to say. Then on the other hand, we have clinker substitution, so lowering the so-called clinker factor in cement. And you can do that by using more limestone, grinded limestone. And you can also do it if you address electricity, because grinding is an important emitter of indirect emissions when producing cement. When looking at concrete, you can cement industry themselves, they think the concrete mix can be better, and you can use less cement within concrete, serving serving the total service, so to say. So you can build the building with less cement there. And what they also hint at is that the built infrastructure today, the buildings, the bridges, etc., within their lifetime, they capture some CO2 from the atmosphere again. So this is actually not recorded in official emission statistics of the cement industry, of course. Yeah, but we see that until 2030, there are no real levers there that address carbon neutrality in 2050 in their roadmap. And this, from our point of view, requires really CCS in this industry. We see that that we probably will need still clinker in the future for all kinds of infrastructures, and also for the transformation process itself with the industry, with the infrastructure needs. So we need to address it, and we can address it also with 2030 as a stage. And Guido, please go to the next slide. There we can see our potentials we identified. These are still rough potentials, but you can see that there are several offshore CO2 storage sites under development now, and mainly in the North Sea. You can see these are indicated with the circles. And on the other hand, we also have in the Mediterranean area one pilot now, which is planned, but most of them are in the North Sea. So this piloted storage sites, they open up really an opportunity to get to a faster reduction of CO2 emissions also in the cement sector. And of course, with this North Sea sites, the sites at the North Sea coast or the Baltic Sea coast are obviously suitable to get CO2 from there to the geological storage. And taking these into account, so the North Sea and Atlantic sites, we ended up with about 9 million tons of CO2, which could be captured at these sites and transported to storage. And if we also include the Mediterranean area with plants in Spain, Italy, and Greece, we would have another about 8 million tons that could be addressed. So by 2030, there could be a really significant contribution of CCS, if we get it ready quick, to additional mitigation in the cement industry. And also, as we have also already biogenic fuel use in the cement industry, that would also have negative emissions. So a part of these 9 million tons would already be negative emissions. Please go to the next slide, Vida. Yeah, and but you may ask, how can we get to a transformation of these sites? So the clinker ovens are there, and so there are now several projects in Europe that are not about really building new clinker ovens, but to retrofit existing ones. And we see in Brevik in Norway, there's a project to build a post-combustion capture plant, so to really, that's an end of the pipe solution, to address the emissions of the clinker ovens there. And they are planning to be commercial until 2024. On the other hand, we have the CCS project of Agora. They have quite a long history already, and they are also planning to build demonstration plants, but this is based, as far as I see, on oxy-fuel technology, so on a new oven technology allowing for higher capture rates of CO2 and a more efficient process. There are also plans not to go to geological storage, but to use CO2, use to catch for climate at Mergelstetten plant. And they plan to produce synthetic fuels based on hydrogen and CO2 from the cement plant. And third, a very interesting technology is actually to go to the calcination process, which is part of the clinker production process. And so the first step, so to say, after the drying of the raw material. And there you can really derive a very pure CO2 stream if you separate the process of calcinating from the off gases from the clinker plant. So traditionally, the off gases from the clinker plant, from the clinker oven, get in contact with the calcinated material. But if you separate that and put the heat in another way to the material from outside, then you can get to a pure CO2 stream. So the process emissions can be addressed very well with this technology. And you can even electrify this process quite easily. So this is our interesting levers, and to get to quicker reduction of CO2 emissions in the cement sector. The next slide, please. Yeah, summing up for the cement industry, if we focus on CCS here, there's clearly something to be done in the regulatory framework. So for CCS, the legal status is not clear enough for the companies to really get into investment. In some countries, for example, in Germany, there needs clarification. So issues are about, of course, so putting the CO2 across a border. So if we get, for example, CO2 from Germany to the Netherlands, to some pilot site of CCS, so there are still issues around such a legal status. And of course, we have, as in the other sectors as well, we have a higher production costs associated with the application of CCS. So about a doubling of costs we have. And so, of course, we need additional business models and also an effective carbon leakage protection. But what we see, this is important, is that some of these plants we would address, especially in the Mediterranean area, they now export actually cement clinker to outside the EU. So at the moment, the EU is an net exporter of clinker and not an importer. So, but of course, with the doubling of production costs, we expose this industry to a risk also of carbon leakage. So for a rapid upscaling of CCS, and this is now in our picture beyond 2030, it needs, from our point of view, a pan-European CO2 infrastructure. We've seen that in Middle Eastern Europe, there are no offshore storage sites available as far as now in the Baltic Sea. So there's really some kind of infrastructure needed. And for the industry, it's important also from the beginning to know how this infrastructure has to be scaled. So also when you start your infrastructure, for example, at a port, it's important that you know that how much CO2 you will have to ship from this port in 10 years or 15 years. So it's important to get to a picture for the industry and for investors for such a scheme in the future. Thank you.
Thank you, Clemens. So we had the broader picture presented by Stefan and 3 sector deep dives. And now are heading more to the questions. We have so far in the Q&A just one question that relates to this topic, the question from Andreas Rieger on the financing of this transformation. I would postpone after the second session because this is clearly linked to policy instruments, and therefore we would like to discuss this in the second stage. I would now ask the question from Georg Kubiela, who asked that there seems to be a strong link of a renewable energy pool and the buildup of green steel capacities. He asked how realistic we see this green steel buildup, especially in Eastern Europe, and whether H2DRI would be an option that is fueled by maybe also blue hydrogen from Russia. And I would take this question and ask the team more broadly, what role would you think in this transformation could blue hydrogen play in the transformation, not only for steel, but maybe also for ammonia and the chemical sectors? Who wants to go first?
Yes, maybe I can take this question as I've been presenting the steel sector. I think it's a very interesting question, and it is not clear yet how the steel transformation will take place. So I presented the two technologies that we think are definitely ready by now. So it is also possible that some of these blast furnace sites that reach their end of life convert to electric arc furnaces. It is also possible that some DRI could be imported from countries that have rich renewables potential, and we see with Sweden that there's a country already moving very quickly on building up this green DRI capacity. At the same time, I also believe that the investment window for DRI capacity is still open, potentially up until 2030, and it's possible to use natural gas, as I lined out as a first step, reducing the emissions already by 2/3. And then blue hydrogen is definitely an option for countries in continental and Eastern Europe that maybe do not have the cheapest green hydrogen available. And we need to find a pragmatic approach for the steel sector transformation in Europe to make use of the things that we do have. And I think blue hydrogen is something that needs to be discussed in continental European countries, because we see that we will need the renewables for a lot of renewables for other sectors to directly electrify transport heat, and also some industrial heat. So blue hydrogen should definitely also be part of the discussion for certain countries.
Yeah, and Georg just mentioned whether this is not a danger of the Eastern European countries being locked in the long-term use of natural gas and not making the switch towards the green solution.
Well, I try to answer this question briefly. I think the biggest risk as of now is that companies either reinvest into coal-based capacities, which would be much worse. And the second risk that you mentioned, that they lock in with natural gas, we need to look at that on a specific country level. But as we do see it with the European hydrogen strategy, there will be a lot of clean hydrogen available. At least that's the plan by 2030. And the big question then is how you allocate the clean hydrogen to the different sectors. And we see a clear priority for hydrogen use in the steel industry. So the lock-in, in my view, is not a very big danger for those countries, because we do believe that we will have enough hydrogen for the steel sector to quickly replace the natural gas, even before 2030.
Thank you, Vito. Camilla, maybe you can have a short also answer what kind of role you would envision for potentially blue hydrogen for the chemical sector.
Yes, I believe that for ammonia blue hydrogen, there will also be complements with the green hydrogen. So blue hydrogen will help with the transformation and building the necessary infrastructure, especially because we cannot use 100% of green hydrogen in 2030 because we need the nitrogen to produce ammonia. So we don't have the air separation unit. The capex of air separation unit is really high. So we'll still need steam reforming from natural gas to have the supply of nitrogen. So yeah, I believe that blue hydrogen will have an important role in the beginning.
Yeah, we got two more questions related to our current discussion. Bernhard Schulte is asking the question that all the technologies we are mentioning are linked to huge amounts of green power. Or where does this come from? What's your idea on that? Who will answer this question?
Maybe I can make a try. Yes, that's definitely right. Different from other sectors like transport or buildings, efficiency gains are much lower in industry. So we will need to replace huge amounts of fossil energy by electricity. I think that highlights how important it is to ramp up investment into green energy in Europe, all over Europe. So, and it's clear that will be onshore wind. It will be lots of photovoltaics, which has become ever more competitive. We have to think about having it on every roof, basically, and maybe also on other places. I think the North Sea can be very interesting. It's a highly techno-economic vision, but we have already, we are seeing plans to have lots of offshore wind there with islands in the North Sea producing hydrogen. And that makes the region very strategic because it's close to the industrial centers, which are, many of them are in the northwest of Europe, you could see in the maps. So that's very straightforward. But I think also importing green energy, maybe in the form of green or blue hydrogen from the east, Ukraine, from the south, southern Europe, from the MENA region, will turn out as other options. So I think over the next decade, we will see a multitude of options, but nevertheless, ramping up investment is extremely crucial here.
Yeah. So everything goes through the route of renewable energy, by the way, and that's the key pillar of European policy and also member states' policy going forward. Clemens, we have one more question in the Q&A. How do we see the role of CCUS in the perspective of the cement industry going forward? What are the challenges here? What's your take on that?
Yeah, as said, in looking in the direction of 2050, we see that CCS is really crucial for the cement sector. There are some potentials we see, and that the cement industry also sees them, to use CO2. You mentioned in your question and answers section, the carbon cure as a potential process. So we see that, but the potential to capture all emissions generated in the initial phase when treating the limestone can obviously not addressed through these processes. So there are some technologies that are under development, and some are to some extent market ready for some niches, and that's interesting. That are interesting things and interesting technologies, but we still, to our knowledge, and that's I think the knowledge we have today on the system, we will need CCS also in the end. Carbon capture and usage, is another point, of course. You could also think of using the CO2 and doing something with it, producing chemicals or fuels even. So we, of course, the origin of this CO2 is still fossil. So then we have to compensate it, for example, anywhere else in the world by doing direct air capture and CCS. So anyway, we need the CCS, I think, to compensate for this fossil CO, for this fossil carbon we use in the cement clinker process. So CCS will be needed, if not in Europe, anywhere else.
Thanks, Clemens, for this elaboration. One point to add, and of course, direct air capture CCS is a technology that comes in very costly at this point of time. There are mitigation costs of today above 300 euro per ton. This always needs to be considered when talking about compensating for leftover emissions that then otherwhere or need to be compensated elsewhere with technology. So we have discussed a lot of technology and strategy as going forward, but of course, the big missing piece you all mentioned is policy, politics, and instruments going forward. And that's why I would assume that we make it more, let's say, clear and visible what our thinking in that direction is. And I would ask Oliver Sator, our senior associate on industrial decarbonization, who is working in Brussels and the Paris context. Please give us a short overview of the policy requirements that we see. Thank you all for the presentation, to the colleagues who have been doing this so far. And Olli, the floor is yours.
Yes, thank you very much, Frank. So indeed, I want to give a brief presentation on policy of priorities to kickstart the EU industry transition, building off what the previous speakers have said. Oh, excuse me. So for those of you that aren't aware, the European Union is implementing a quite ambitious new vision under this European Commission called the European Green Deal. This is a huge package of policies which increases the EU's greenhouse gas emissions reduction targets to achieve a minus 55% goal by 2030, to achieve climate neutrality by 2050. And there's a whole bunch of sector-specific pieces of legislation that will go into implementing those new targets. The question we have to ask, though, is, well, there'll be a lot of new policies, but will those policies actually do what we need for the industry transition and to unlock those technologies we've been talking about? So how should we think about this problem? Well, one way at Agora we like to think about this problem is in terms of the different parts of the value chain. So in a way, you can break up this problem into 3 or 4 pieces. So first of all, you have the upstream part of the value chain. So the infrastructure, for example, we were just discussing. So here we need to expand access to affordable clean energy, to CO2 infrastructure, of course, and to clean feedstocks for these processes. Then if we focus on the midstream part of the value chain, we need to make sure that these climate neutral process technologies can be competitive. So they can have a business case in the European market compared both to conventional high carbon technologies, but also compared to possible imports from overseas, which might not have the same level of environmental performance. We also need, as Camilla said, to decarbonize their energy inputs in these industrial sites by switching, for example, to power-based heat sources using clean electricity. And then downstream, what we have to do is to develop markets fundamentally for these new low carbon materials and low carbon processes to actually have a long run business case and to be able to scale up massively. So we need market demand for climate neutral materials, but also for these other levers like material efficiency and circular materials. And if we want to do that, then one of the things we have to do is to enhance the quality of recycled materials and remove barriers to the recycling and reuse of materials in these different value chains. So I want to start off actually on this point of circular economy because in a way it helps us to frame the challenge. This graphic here that I presented comes from a report by Material Economics, the consultancy, which argued that actually for steel, plastics, aluminium and cement, roughly half of the greenhouse gas emissions of today could be reduced if we really pulled all of the possible levers for material efficiency and for a circular economy. Now, in practice, some of these might be challenging to implement, so maybe the real potential is a little bit lower than that. But nevertheless, it's important to bear in mind that given all the challenges of deploying these large-scale infrastructure and the demands on the power sector and so on, the more we can reduce this challenge, the easier we make the task for ourselves. One of the ways we can do this is by having a stronger link between circular economy policies. So, for example, the Circular Economy Action Plan of the European Commission and our industrial CO2 strategy. So one thing we need to do is to focus maybe not only on plastics. Plastics is obviously important, but also on key materials and value chains like concrete and cement, construction, metals, vehicle manufacturing, and so on. And there are a bunch of policy tools we can think about including improved design, the way we handle materials at end of life, collect and sort and trace, and the way we create demand for recycled materials to start to implement those policies. And of course, all of that needs to be done in a way that creates a business case for companies to be more circular. But then we will still need, the circular economy will only get us so far. We will still need to develop new low carbon ways to produce virgin materials. And so for this, we need governance, finance, and appropriate sustainability criteria to deploy this key low carbon infrastructure for our industrial clusters and for our industrial sectors. And if we want to do that, then one of the things we need to get better at doing is, first of all, making people responsible. So we need to assign a responsibility for who provides that infrastructure, and also in some cases to have either public or public monopoly financing of some of that infrastructure, because it is extremely capital intensive and involves higher risks for individual companies or sites in the industrial sector to manage. We also need to make sure that our sustainability criteria for key inputs like green hydrogen strike a balance between what is compatible with the transition to climate neutral Europe in 2050 and also what we can actually start to implement immediately, because we need to get started today as well. And so we need to think carefully about the way we time the phasing of some sustainability criteria. If we focus then on the midstream part of the value chain, so in the EU, there's a lot of discussion about a carbon border adjustment mechanism, or CBAM, as I call it here, and carbon pricing. The problem, however, is that while these policies may have some role to play in the transition, they will not solve all of the problems. So what this graphic here shows you is that for a set of key climate neutral or low carbon technologies, in the steel, chemical, and cement sector, the marginal abatement cost, which is the horizontal axis, is typically much more expensive or a bit more expensive than the current level of the carbon price of around 50 euros a tonne. That's a challenge, because that means at the moment there is no business case for these technologies, even with the high carbon price we currently face. In addition, we also have to be aware that even if carbon prices are to rise a little bit in the next 5-10 years, the volatility of the carbon price, the uncertainty that it provides, can also be a barrier to investment in very expensive, capital-intensive, first-of-a-kind technologies. So we have to manage this risk and sort of to help the deployment of the first kinds of projects in these key sectors. Now, one of the ways that at Agora we think this can be done is through the deployment of so-called carbon contracts for difference. The basic idea of carbon contracts for difference is that you have the EU ETS carbon price raises the cost to a certain extent of conventional technologies, but there may be an incremental cost in addition that we need to support for a time to help deployment of these low carbon technologies. So the idea of the CCFD is effectively to provide a guaranteed carbon price at the level necessary, at the marginal abatement cost of these key low carbon technologies. Now, there are different options and scenarios for how a carbon contract for difference might actually look in practice. And to be honest, in the three different options are presented here. There are, in effect, the scenarios depend a lot, to be honest, on what happens to the anti-carbon leakage policies that the EU has. So, for example, in the first scenario, you have the free allocation is continued to conventional technologies, and therefore it eliminates their ETS carbon costs. The incremental technology therefore needs to be paid the full abatement cost to cover the cost gap. In a second scenario, you can imagine giving free allocation also to the low carbon technologies at the level of the benchmark of the high carbon technologies, in which case the carbon contract for difference would just cover the difference between the carbon price and the incremental cost for the new technologies. This is currently not necessarily the default rule under the ETS, by the way, which tends to align more with scenario one because of the way the benchmarks are defined in the ETS. And then we have a third scenario, which is if the EU implements a carbon border adjustment mechanism. In that case, the costs for conventional producers would rise because there would be no longer any free allocation of allowances to the conventional technologies. They would have their allowances auctioned to them. But in this case, the carbon contract for difference would just cover the difference between the incremental cost and the cost, the higher cost now of the conventional technologies. A key question one might ask is, well, how would we fund these carbon contracts for difference? Well, In the EU, we think we probably need a double-pronged approach. So at the EU level, the ETS Innovation Fund, as Vito mentioned, could be expanded under the current revision of the carbon market. And we think that an amount of, for example, 5% of the allowances in the market could go into that fund every year to effectively create a significant firepower for a European approach to support technology development across the entire EU. So making sure that there's not a divide, for example, between Eastern and Western Europe. At the same time, though, developing such a fund would take some time, and we need to get started urgently. And so we think it's also important that member states are enabled to move forward in the meantime if they wish to with their own carbon contracts for difference. And here they would have two options to fund these. So one would be to effectively recycle some of the new auction revenues that they may gain if a carbon border adjustment mechanism is gradually phased in. And free allocation therefore would be reduced a bit. So there would be some additional allowances sold to industry, and potentially that money could be recycled to those industries to support their decarbonisation efforts. So that would be one option. The risk, of course, with this approach is what would happen if the CBAM was not phased in, or if it was challenged legally and did not hold up. So a second alternative would be for member states to implement sort of a 1% value-added materials charge, for example, on CO2 intensive final goods. So these would be things like buildings, public works, automotives, perhaps packaging. And we think that a very small charge on the downstream products could raise a very significant amount of money to fund upstream infrastructure and innovation. So there are different options we see there. My final slide is just on the downstream part of the value chain. So here, as Vito mentioned before, what we need to do is ultimately to create a way to scale up massively the investments for business and infrastructure beyond just the support mechanisms of something like carbon contracts for difference. And so one of the ways that we think we could do this would be to put limits effectively on the embedded emissions in material intensive final products, so again, vehicles, buildings, packaging, for example, and to reduce these limits over time. Now, why would you do this? Well, partly because by doing that, it would effectively force all producers of final products to source their materials from low carbon suppliers. And in so doing, it would basically create a willingness to pay along the value chain and a demand for climate neutral inputs to intermediate products who then demand it from basic materials, who would then demand it from their energy and raw material suppliers. Another justification for doing this is also that it would create incentives not just for low carbon virgin materials, but also for material efficient design, for example. So we need to unlock material efficiency in the way we design these final products. And also it would create incentives for substitution, for example, to circular materials or innovative material alternatives. So this is perhaps a relatively less distortionary way than, for example, quotas on intermediate products to create demand. The condition, though, to implement this, however, is that one needs to have much better data than we currently have on the embedded carbon in the different products along the value chain. This data must be transparent and comparable for the downstream purchasers of the inputs. And that requires making some reforms under the Sustainable Products Initiative that the European Commission is putting forward to improve the quality of some of those product category reporting rules and also require that companies pass on the data through some sort of material passport or labeling. So this is perhaps the way we scale up beyond the initial phase. So thank you very much for your attention, and I look forward to answering your questions.
Thanks, Ollie. Very interesting. So the point you mentioned last, that product requirements or better data on the carbon intensity and embedded emissions is becoming crucial. This is a valid point for many of the instruments going forward, I guess. Ollie, we have a first question in the chat that is asking whether a potentially CFD scheme could potentially affect carbon prices in the EU ETS. Since you are also an economist by training, what would be your answer on that?
Sure. Yeah, no, it's a good question. So there is some analysis now being produced by different consultancies on this option. What some of the preliminary analysis suggests is First of all, it depends how big your CFD is. So if you have a program that is really supporting, for example, the deployment of the first X% of technologies in the market, it's probably going to be a relatively small amount of CO2 abatement relative to the total ETS cap initially. So that probably would not be a big problem. A bigger question would be if we scaled up CCFDs very significantly to fund, for example, 50%, say, or more of the relevant product or production sites in the market. In this case, it might have an impact. That said, it doesn't necessarily have to. So, for example, the ETS now has a supply-side adjustment mechanism called the Market Stability Reserve, which has the purpose to basically reduce the number of excess allowances in the market if other policies drive faster abatement. And we think that going forward, there's going to be increasing overlap, not just between CFDs and carbon pricing, but other policies like renewable energy deployment, coal phase-out policies, etc. So fundamentally, we think that we shouldn't ignore key policy instruments for the sake of raising the carbon price. Rather, we should tweak the carbon market to complement the other policy instruments that we need.
Thanks, Olli. And I would also like to come back to the question of Andreas Brigger. He asked it in the first session on financing the green transition. He's asking, the German IMK Institute suggests that the EU member states should invest in companies rather than just put in support policies and to promote those climate-friendly business practices. This could be financed by state equity funds. Advantage would be support industries to meet 2030 targets, sustain well-paid jobs, and prevent foreign takeovers. Olli, or maybe also other colleagues in the chat, in the room, what would be our answer on such an idea?
Well, that's a very different approach, I think, to what we're suggesting. I think that we need to be a bit nuanced in the response here. It's true that in the wake of the COVID crisis, that some of these companies have suffered very severe hits to their profitability. And in that context, there is likely that there will be some kind of quote-unquote bailouts for certain companies. And that could potentially be desirable, in which case one should potentially attach those sort of bailouts to some sort of conditionality on environmental performance going forward, perhaps linked to some of the policies we're talking about, like CFDs. One has to be careful, though, about a company-based approach, because that could easily be a process that's captured effectively by the most powerful companies. And we know that for this low-carbon transition, we will need a range of technologies, a range of innovative new materials. And therefore, one of the advantages of something like carbon contracts for difference, or these downstream demand creation policies, is that they can actually create competition, either through the tendering process or through the incentive structure, to allow the sort of the best to rise to the top. So I think we need to be careful not to go too far down the road of being very close to companies that may pursue their own interests at the expense of the broader transition as well.
Thanks, Olli. I would like to add, maybe this is becoming an option for the infrastructure projects, however. So setting up the infrastructure in advance for carbon capture storage, or even a hydrogen infrastructure, there are, of course, discussions where private-public partnerships, maybe also the state investing upfront in the infrastructure development and then maybe selling it to the private sector again, could be an approach to mitigate risk at the beginning in order to solve this hand and egg problem somehow. So this approach is under consideration, but I would see it more linked today to the discussions to the infrastructure that we need for doing the industrial transformation. So, since there are no questions out there, I would come to the end of our webinar to conclude. Well, we have learned today that most of the technologies are, well, at least ready to be deployed at larger scale. We are missing currently still large parts of the regulatory framework going forward. So this is putting a lot of pressure, but also needs on the current legislative cycle that is running in Brussels on the Fit for 55 package. We're also expecting in autumn key European policies to be reframed, for example, when it comes to state aid guidelines. So we are in a very exciting time, but still we have lots of things to do, especially on the regulatory basis. And also the member states that are sitting on huge industrial asset base at the moment have still to do their homework to get the policy and regulation in place with then hopefully the foundations laid in Brussels later the year. That's what we are heading in over the summer, and what will keep us definitely busy in informing the debate on industrial transformation, the different levers that are potentially out there, the different strategies, and the policy needs. We will continue to do so. We hope others join this discussion at the EU, but also the member states level. And we will clearly see us later in the year in talks across all the European institutions, but also in member states to discuss the topic of industrial transformation. Thank you for your attention from my side, and I now hand back to Nicola to wrap up the whole meeting and the whole conference.
Or deliver the last advertising block of this webinar. Thank you everyone on the podium for your presentations and also for answering and being there for the questions of the audience. Thank you to the audience for being with us until now. I would just like to mention once more that you can find the 2 presentations which were shown during the webinar on our website, and they should have appeared several times in the chat already, and hopefully Maxi will add them once more. You can also find once more the link to the study which was presented during the first part of the event. And in order to be always kept up to date, I strongly recommend to register for our newsletter, where we usually send you information when there's something new on the website, be it a study or an upcoming event or a blog or something like that. And we will have more events in the next month until mid-July. I think we have something in the pipeline, and you will find it if you click on our events site, and you can obviously register if you're interested. And with that, maybe I ask Maxi and Philip and Paul also onto the stage. So we have the full Monty here. And with that, we'd like to say goodbye. Wish you a good rest of the day. Stay healthy, and hopefully see you soon. And we'll be a bit longer on the podium in order not to kick you out too abruptly. So yeah, take care. Bye-bye.
Bye.